So in this video, we're going to find the area of squares and rectangles and then use our knowledge of area to find missing values. Now, before we actually start working with area, we need to talk about what area is. And what most students know about area is talking about this region, this space that is enclosed by a shape. So most students know that area is a 2D measure that's measuring what type of space is covered on the inside. So on the next slide, we're going to break that down further. But remember, with area, we're looking for the space inside. Perimeter is along the outside, and area is the space on the inside. Now, area is a measure of the region enclosed by a 2D figure. So as we said on the last page, if we had, a rectangle with some measurements on it, we don't know what they are, it's this whole space on the inside. Now, it's measured by counting or calculating the number of square units that completely fill it. So this means we have 1 by 1 squares, and we're basically trying to figure out how many of those 1 by 1 squares fit inside of this shape here. The squared that is on there, because we know that area has units squared, is actually telling us about the 1 by 1 squares of space that we have enclosed in that shape. So if this doesn't make sense to you, hopefully the next slide will break that down a little further. But what you need to know about area is it is about the region that is enclosed by a 2D figure. Now, to help us visualize this a little bit more, let's actually draw a shape on here. So let's say we had a rectangle with 3 units on one side. So here we're going to go 1, 2, 3, and 2 units on the other, 1, 2. So here we have our rectangle. Now, we have 3 units here and 2 units here. And what area is talking about when we calculate area, it's how many of these little 1 by 1 squares are enclosed inside of this shape. So here we can see we have 1, 2, 3, 4, 5, 6. So because we have six little boxes, 6 little 1 by 1 squares enclosed in that shape, our area is equal to 6. Now, most students know that when calculating the area of a rectangle or a square, that we can simply multiply the 2 side lengths together, 3 times 2. Now, the reason this works is because that calculation is helping us to find how many squares we actually have on the inside of that shape. So in this video, we're going to specifically focus on the area of squares and rectangles because every set of shapes has their own equation for area. We're going to focus on them one at a time. So here we have the area of squares and rectangles, and the area of squares and rectangles is calculated by taking your base, which is 1 side length, times your height, which is a 2nd side length. So because of those 90-degree angles, our area is calculated by taking just the base side length times the height side length, and we'll find how many squares are contained on the inside of that shape. So now let's apply this to the shapes below. So if we look, it says calculate the area and the perimeter of the rectangles below. So let's start with the area of this first rectangle. I know that area is calculated for rectangles by taking base times the height. So I can see that my base is down here, that's 5. And my height is 11, which is right here. That's how tall my shape is. So my area is calculated by taking my base value, which is 5, multiplying it by my height value, which is 11, and as a result, we end up with an area of 55 feet, and because it's how many squares fit on the inside, it's feet squared. So that's my first one. I can find my area by taking base times height. Now, my perimeter, on the other hand, if we remember what perimeter is, perimeter adds up all of the side lengths together. So we have 5 plus 11, which is 16, plus 5 more, which is 21, plus 11 more, which is 32. So our perimeter is 32, and it's just normal feet because it's the distance around. So now if we look at this second shape here, again, our area is calculated by taking base times height. Base is 10 times height is 8. So we end up with 80, and then it's inches squared because it's the number of squares that fit on the inside. And then our perimeter is again adding up all of those side lengths. So we take 10 plus 8, which is 18, plus 10 more, which is 28, plus 8 more, which is 36 inches. So what we're going to do on these last few slides is we're going to actually use what we know about area to now find missing values within a shape. So we're going to use our area equation, which is base times height, as our baseline, and it's what we're going to fill in so that we can then solve for missing values. So here we can see that the area of the rectangle below is 45 feet. So if I know my area equation is area equals base times height, and I know area is 45, I'm going to fill in area and write 45. Now, our base, we can see here, is x. So I'm going to replace it with x. And then my height, I can see right here, is 5. Now, if you don't like how that's written, multiplication is what's called commutative, so it doesn't matter which order we multiply in. So you can rewrite this as just 5x if you would like. It's the same thing. Now we just need to solve this equation, which we can do by dividing each side by 5. We find that x is equal to 9 feet. So now let's try a slightly more challenging example. So here we again have area that is given to us. It says the area is 80 centimeters squared. So here I know that area is calculated by taking base times height. So I know my area is 80. My base is x plus 3, so I'm going to put parentheses around that. And my height is 10. Now again, if I don't like the order in which that's written in, I can just flip that around to be 10 times x plus 3, because multiplication can be done in any order. And then from here, I simply need to solve the equation. Now I see parentheses, so one thing I can do is I can distribute. So I have 80 is equal to 10x plus 30. I can then subtract 30 from each side so that these cancel out, and we're left with 50 is equal to 10x. I then can divide both sides by 10, and I end up with x is equal to 5. So I have x is equal to 5 centimeters as my final answer. And essentially, if I were to put that in here, I could do 5 plus 3 and find that my side length is equal to 8 centimeters. And final example here. So again, we're going to use that same area equals base times height example. And so I know my area is 75. I then know that my base is right here, which is 5x. Now, I can put that in parentheses if I want, but there's nothing being added with it, so I don't need to. And then I have a height of 5. Now, this piece right here, 5x times 5, there's no distribution here because there's no plus sign or minus sign in there. Those just multiply together to be 25x. Now I can solve this equation by dividing each side by 25, and I find that x is equal to 3. So I know x is equal to 3 inches. And what I can do is I can place that x in here. So I take 5 times 3, and that gives me a side length of 15 inches.